ready to dive into the world of equal parts. That is what we are going to be talking about for a little bit together. So this is one rectangle, and I want you to imagine that it is a maple long john, and Mrs. Bastion is going to eat that whole maple long john. But all of a sudden, Miss Lexi comes over and I can't eat that whole maple long john. I have to share. So if I share that maple long john with Miss Lexi, then Mrs. Bastion would get half and Miss Lexi would get half, and two halves make one. And that's what we call that when we have two parts. We call it halves. Two halves make one. Now, that is awesome. But then all of a sudden, Blaney Boy comes over and we can't be rude and not share. So can we divide this maple long john into three parts? Of course we can. So we're going to take this maple long john and we were going to divide it into three parts. As you can see, we would have to make two lines to divide it into three parts. There's a line and there's a line. And we would share because there's one part, two parts, and three parts. And when we have three parts, we call that thirds. All right, because there's Mrs. Bastion, Lexi, and Blaine. There are three of us, so we call that thirds. All right, now there's someone else at the door. It is Brody. Brody must have smelled the maple long john too. So he comes in, and can we divide this into four parts? Absolutely we can. So we are going to take this and divide it into four equal parts. And if we divide it into four equal parts, everyone's going to get a little taste of that maple long john. And if we divide it into four equal parts, that's called fourths. And we are going to enjoy that maple long john. As you can see, when we have one whole part, two halves equal one, three thirds equal one, and four fourths equal one. Now, as you can see, we have this hexagon, and we need to figure out which of these shapes could fit in this hexagon. Do you see the red blinking trapezoid? We can go ahead and put that red trapezoid in there, and you can see that it fits in there just like a glove, right? Now, how many of these do you think we could fit into this hexagon? I think we could fit another one. Let's go ahead and put it in there. So now it shows that there are two equal parts to this hexagon. Two trapezoids equals one hexagon. Now, do you think that there's another shape that we could use to also fill up this hexagon? It's blinking the green triangle. Let's go ahead and see what happens. We could put a green triangle, and let's go ahead and do another one. Look at this. So, how many triangles do you think we would need? Let's go ahead and fill it up. There are 6 equal parts. So there's 1, 2, 3, 4, 5, 6 triangles would equal one hexagon. So 6 equal parts of a triangle would equal a hexagon, and 2 equal parts of a trapezoid would equal a hexagon. And we consider this one whole green rectangle. All right, now we're going to click it and we're going to divide it in half by just creating a line. As you can see, the line makes two halves that are equal parts. Now, what if we drew a line down the middle? How many parts would we have? We would have 4 equal parts. And then we call these fourths because there are 4 equal parts to the green rectangle. 1, 2, 3, 4. There are 4 equal parts. And we say 4 fourths. Now in our green rectangle, we have created 2 lines, which gives us 1, 2, 3 equal parts to our rectangle. And as you can see, we call this 3/3. All right, when we have 3 equal parts, then it's considered thirds. They want us to find the drawing that shows halves. And when we find halves, we're looking for 2 parts. It's just like taking an apple and splitting it down the middle. You have 2 parts. You have 2 halves to make a whole. And which one can you see that is split just in 2 parts? That would be the triangle with the one line. This side and this side are halves. When you look at this square, how many equal parts do you see? Let's go ahead and count them. 1, 2, 3, 4. So there are 4 equal parts inside the square. Now, what do we call these? We call these halves or fourths. Is it split in 2 pieces or 4 pieces? It's split into 4 pieces. So we call that fourths. So there are 4 equal parts, and this is called fourths. Can you tell me how many equal parts are there in this whole trapezoid? There are 2 equal parts. So if we write the 2 in that box, that would mean there are 2 equal parts. As you can see, this side is 1 and this side is 2. And what is that called? Do we call it fourths, halves, or thirds? When there's only 2, we call them halves. How many parts are in this whole circle? There are 1, 2, 3 parts. So we would say there are 3 equal parts in the circle. And what does that tell us? Does it tell us that it is thirds or halves? Well, when we have anything with 3, it is third. How many equal parts are there in the whole of this rectangle? Now you can see they have drawn 2 lines inside, which gives us 1, 2, 3 equal parts. So we would put 3 equal parts. And what are these 3 equal parts called? Are they fourths, thirds, or halves? We know if it's 3, it means that it's thirds. Can you please show me which drawing has fourths? Fourths means 4, right? So as you can see, it would be this circle B, because there are 4 equal parts. This circle down here, we would say is in 3 equal parts. So we would say thirds. And then this trapezoid, it only has 1 line. You can see they've split it down the middle. So that would be halves. If I said, what is the name for 2 equal parts of a whole? What would you choose? Thirds, halves, or fourths? I hope that you would choose halves, because that means 2. It's been a long time, boys and girls, since I've shown you a math on the spot. I'm sure you're probably missing them a little bit, so I thought I'm going to let you guys watch this one today. So Professor Berger has this to share with us.
Hey, Joey, what are you wearing?
That's Detective Joey to you, and I'll ask the question.
Oh, great, because I actually wanted to talk about a question involving fourths and equal parts.
Oh, well, give me the facts, Professor. Just the facts.
Absolutely, only if you'll help me.
Of course.
Great. So the challenge for us is to see if we can draw to show fourths. And we have to explain why, in fact, we know that the parts are really fourths.
Okay.
So fourths just means that we take some shape and divide it into 4 equal parts.
Well, let's try it.
Okay, sure. So let me first of all show you that you can actually physically do this. You take something like a square. If you take a square, you can kind of fold it like this. I'm going to fold it in half this way. There's lots of ways of folding a square in half. I'll just do one way really fast. So here's one way. And so now we have 2 equal pieces. So these are actually halves. But we want, in fact, fourths. So I'm going to cut it again. I don't know if you're going to be able to see this or not, but it's going to make these 4 little nice triangles that all come together in a nice way. Let's see how nicely you can see this.
see.
Hold on. Everyone calm down. There we go. Look at that.
Oh, that's pretty cool.
And you can see that each piece, in fact, is equal because they folded on top of each other perfectly. And you can see they all match up perfectly. So, in fact, this is a great model for fourths. And in fact, I'll show you what the drawing would look like. You can draw it just taking a square and putting in the two diagonals. That's what we call them, diagonals. And it would look something like this. You see, so here's a nice pretty version of that.
Looks just like it.
Exactly. And so, if I were to move this over here, then if I want to kind of fill in the blanks, I can see for ourselves that how many equal parts do we have? 1, 2,
2, 3, 4.
Exactly. And so I see that we have 4 equal parts, and that means we have fourths. And I'm going to write that in, fourths. And so, Detective Joey, we see the answer to the riddle. We know that, in fact, we have fourths because each one is equal to each other. And I've taken a shape and divided it into 4 equal parts. So I have 4 equal parts. That means fourths. What do you think, Detective Joey?
I think you have great detective skills, Professor Berger.